So why the InfiniMitts? Well, besides the fact that they just straight up look awesome, it's also more ergonomic. You're not sitting there crouching over your computer, hurting your wrists and stuff. You're free to move around. Here I can type on my leg. I can move my mouse like this. I'm not restricted to a desk. Also, think about all the desk space you'll save. You no longer need space for your mouse or your keyboard. I mean, where am I going to put a mouse right here? Also, what we're going to talk about a little bit later is you don't even have to use this as a mouse.
So, how does it all work? Well, here we have 5 FlexiForce sensors, which essentially act as piezoelectric buttons. We have these connected as voltage dividers going to ground and 5 volts. And then over here on the left hand, we have flex sensors that change the resistance as Steve does that. And these are also connected as voltage dividers. And then here under these, we have the accelerometer that actually measures the tilt that controls the mouse. And at the heart of the entire project, is the Arduino. And if you want to see how that's all connected, here's our schematic.
So here's the code for our setup. We're going to be using an Arduino Leonardo as a USB mouse and keyboard interface. We start off by including the library for the accelerometer that we use, the MMA 7361. And then before the setup, we go ahead and just define some values that we're going to be using, as well as which are the input pins we're going to be using as well. We get into the setup here, and we tell Arduino that we're going to be using it as both a mouse and keyboard with the mouse.begin and keyboard.begin commands. And then we go ahead and define how we're going to be using the accelerometer, what pins we're going to be using, and then we go ahead and calibrate it. We calibrate it by reading some values, just 200, and we take each of those values and pretty much find the average of what it's going to be, so that way we know there's not going to be a lot of excess mouse movement, just background noise pretty much. So here we are getting into the loop, and immediately we tell the accelerometer to start taking readings, because that's how we're going to be controlling our mouse with some of those analog inputs. We define what the X and Y readings should be, and then we map the actual readings from the Arduino to the range that we want to move the mouse. We then go ahead and tell it to actually move the mouse with the mouse.move command, and then throw a delay in there so that it can take the next reading at a significant time after that. Then, using some thresholds that we determined from the flex sensors, we tell the mouse to either press its right button or left button based on the position of the flex sensor on the fingers. And then, after we've told the mouse how to behave, we go ahead and start deciding what we're going to be doing with the keyboard and what keys it's going to be pressing. You'll see this if analog 3 or analog read 3 is less than the threshold for all of the keyboard presses. If the analog read is above the threshold, that just means that the thumb is in a position such that if it's straight, which means that it's going to read one set of keys and the mouse is going to behave one way, whereas when you bend your thumb in, it starts telling the accelerometer to act as the arrow keys, and also you get a whole new set of keys to work with on your right hand.
As was previously mentioned, these InfiniMitts don't even have to be used only as a keyboard and mouse combo. By writing a program that will read different things from the sensors and respond differently to sensor input, you could make such things as a mobile music machine, where these control, say, percussion, and the flex sensors can control a trumpet. Doo, 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 doo. As you saw, we were using the InfiniMitts to play a video game. That was an emulator on the computer, so it was basically a keyboard. It was still being used like a keyboard, but we could even program the InfiniMitts to be compatible with, say, an Xbox 360, a PS3, with plug-and-play capability. You could even drive a remote control car with them. Just like you can use apps to customize the functionality of a smartphone, we propose to create modules to customize the functionality of the InfiniMitts. These modules would contain the programming that is needed to interface the InfiniMitts with whichever device you're attempting to control, whether that be a computer, a console gaming device, a smartphone, a tablet, or a remote control car. In order to rid ourselves of the need for different connectors to connect the InfiniMitts to different devices, like, some use a micro USB, some use a regular USB, some don't even use USB at all. We propose to incorporate Bluetooth connectivity so that we can hook up to anything, multi-platform functionality. Also, an added benefit is that it would get rid of these clumsy things.
Even though we were able to think up the InfiniMitts, which was a great idea, we can't actually think up money to just do it all. So, we need some funding, because apps and modules aren't going to write themselves. And while Bluetooth capability is magic to some people, for us it's a problem that actually needs to be solved. Also, although these guys look pretty cool right now to us physics majors, what we would need to do is pretty much make these a lot more user-friendly, get rid of these clunky wires and these sensors outside. After making all these improvements and streamlining the model into something that we believe is going to be a marketable product, we're going to go ahead and actually manufacture our InfiniMitts. What we want to do is initially produce 250 InfiniMitts and then also 150 of 3 different module types. All in all, we've done some rough calculations and calculated this to be around $50,000 for our initial startup costs.
To encourage potential donors to help us achieve this goal of $50,000, we're offering the following incentives. If you donate $25, we'll send you a thank you card filled with our deepest gratitudes. If you donate $50, we'll include your name under the founding contributors portion of the pamphlet that we will include with every purchase. For a $100 donation, Steve will bake you a loaf of his own banana bread that's really, really good. And of course, you'll also get your name in the founding contributors portion and a thank you card as well. For $250, we'll give you a voucher to buy all 3 for all 3 modules free when you buy a pair of InfiniMitts. For $255, you can also get the banana bread. If you donate $500, we will gift you both gloves and a module of your choice. And for $502, you'll also get the banana bread with that. And if you gift $1,000 to us, we'll give you both gloves and 3 modules. And for only $1 more, you'll also get the banana bread. So associated with this undertaking are some risks and challenges. Generally speaking, in trying to reduce the price of the InfiniMitts, we need to make sure to not lose any functionality. Specific to the mouse and keyboard combination, we're concerned that people are very comfortable right now with the current setup of a physical keyboard and a physical mouse, and we're worried that maybe they won't want to change their ways. Additionally, an issue that we have with the keyboard is how to provide all the keys in an accessible and intuitive way.
So in doing this experiment, we actually learned quite a bit about using the Arduino and interfacing with USB devices. One of the first things that we learned, and one of the first things that we had to kind of overcome, was the fact that the Arduino Uno, it can send serial commands and receive serial commands on a computer, but it can't be recognized as a USB device like the Leonardo can. And so while we were able to send serial commands and do stuff like that, another program we use processing actually is required to do any kind of USB interface.
So we wanted it to be plug and play, so we ended up getting a Leonardo to use its built-in commands for moving the mouse and doing the keyboard instead of the Uno. One of the interesting things we ran into when we made that switch was that the digital variables for the Leonardo switch at 1.55 volts between 1 and 0, whereas with the Uno it switches at 2.5 volts. So we had to go through and redo our resistors.
Also, speaking of resistors, another thing we learned was that we had a really large, on the order of 10 mega ohm resistors, a lot of them going into the Arduino, and we were having some issues with that, and what we found was that when we measured the resistance across them, for some reason when you have a whole lot of resistance going into the Arduino ports, the actual resistance across the physical resistors is a bit lower than what is actually measured otherwise.
Significantly lower.